In this session of our DevOps, we will be building a DevOps project from the scratch using Terraform Jenkins on AWS Cloud. Let's break down this whole project into three categories. And the first category I'm talking about is the tools. So we will start by using the Terraform. Second, we'll also use the Jenkins for building our CI/CD pipeline, and AWS going to be our preferred cloud option. The second category I'm talking about is the application. And for the application, we will be building a REST-based web application where we will be having some REST endpoints. And those REST endpoint application will be able to store the data onto the database. That will be our RDS instance using MySQL. And this whole application is going to be our Python Flask application. The third category I'm talking about is the AWS component and the services. But before we set up our DevOps project, we need to know the flow of our whole project on a high level. So for that, we will be using a domain, which is my own custom domain, which I have already purchased, which is jhook.org. And this domain will be using to access our REST API services, which is deployed onto our EC2 instance. And that EC2 instance will be able to store the data onto our RDS instance, which in our case is MySQL. So this is going to be our flow for this particular project. But to implement this particular request flow of this particular DevOps project, we need to enable certain component and the services of AWS. So let's take a look onto the components individually. So first we will also work on the Route 53, which is a AWS managed service for managing the domain request. Second, we need to set up the whole networking for this particular project, and for that we will be using the VPC, then we'll be using the subnet, then we'll also try to set up our internet gateway, then we need to set up our route table, and at last we need to set up our application load balancer for our EC2 instances. One side note for you for this particular project, this whole implementation is very generic, and although we are using the Python based Flask REST API, but you can just replace that whole component with Node.js or any other application, and rest of the infrastructure setup, CI/CD pipeline will still remain the same. Let's jump to the demo, and before we begin, I have divided the whole project into three different GitHub repositories. So the first GitHub repository I'm talking about is the Python application, which is our Flask based REST API. So that is going to be our first GitHub repository. Second GitHub repository I'm talking about is the Terraform and AWS. So our whole infrastructure provisioning will happen with the Terraform. So all the infrastructure setup we will be doing using our Terraform as our preferred tool. And the third GitHub repository I'm talking about is the Jenkins, where we will be setting up our CI/CD pipeline using the Jenkins. I will also share the GitHub repository link into the description section, but here this is my first GitHub repository for my Python application, which is a REST-based application using the Flask. This is the second repository where I'll be storing my Terraform code for provisioning the whole AWS infrastructure. Here you can see all the certificate manager, EC2, hosted zone, all the networking and the infra related modules. Third is our Terraform Jenkins GitHub repository, which will help us to set up our Jenkins onto our AWS cloud. If it sounds overwhelming at this point of a time, then I would highly suggest to pause this video at this point of a time and take a look onto this particular slide where I highlighted like what are the different components I will be working in these three particular repositories. Alright, so let's move ahead, and the first component we will be setting is our Jenkins. And if you move to the next slide, then this is the Jenkins setup we need to do. And for any setup we will be performing throughout this DevOps project, we will be setting up our VPC. So for Jenkins, the first thing we need to set up is the VPC. So here you can see this is the first boundary where you can see our AWS account, but inside that AWS account you will see a VPC, and in the VPC you will see a IP range. So VPC is going to be my virtual private data center, and in this VPC we will be setting up all the components which relates to our Jenkins. Now we need to set up the VPC, so I would recommend you to just clone this particular GitHub repository, and here you can see onto my IDE I have already cloned that particular repository. And in this repository there are certain modules which I have already created, but these modules we will go one by one, and we are just start enabling those modules one by one. So the first thing which you need to take a look onto this particular GitHub repository is the main.tf file, which I have highlighted over here. So just open this main.tf file over here, and here you will see quite a lot of modules. There is a networking, there is a security group, there is a Jenkins module which will install the Jenkins. There is a load balancer target group. Then there will be an application load balancer, and at last we will see a hosted zone for domain as well as for the certificate manager for managing our certificates. But we are just gonna target each module one by one. So the first thing is we need to focus on our networking. So first thing which you need to set up is the VPC. So for that, what I'll do, I'll just disable all these modules. So I'll just comment all rest of the modules, so that we only know like how to set up our VPC for Jenkins. So I have commented all this section. So let's take a look onto this networking module, and I would highly recommend to install the Terraform onto your local machine while working with this particular repository. So here, this is the networking module as I have named it. So in this same GitHub repository, you'll find a networking folder over here. So this is the networking folder where I have placed all the code relates to my networking. So just open this one, and you will again find a main.tf file that is going to be our module's main file. So just open this one, and here you will find a resource which is like a AWS VPC. So if you take a look onto our slide, so here you can see this is the VPC which we are trying to set up. And when you are using a Terraform, then this is the code block which you need to use for creating your VPC. So the resource name is AWS VPC, and this is a custom name which I have kept it, which is like a dev project 1 and VPC EU Central. I think it's not a EU Central. I have put it a wrong name over here, but it is a EU West one. So just keep in mind. So this is the resource, and this is the custom name. It doesn't matter. Just keep any name of your choice. And here, this is the CIDR block. This is going to be my IP range for my particular VPC. So if you take a look onto this slide once again, so the IP range is 11.0.0./16. So this is going to be the IP range of my VPC. And here I'm passing it as a variable. So here you can see VPC CIDR, and if you take a look, so this is the variable which I have been passing to this particular module. And if you take a look onto the main.tf, then here we will be passing that particular value from here. But here we have declared it as a variable. And where to find this value? So if you go into the Terraform tf.vars, then here you will find the VPC CIDR, and this is the IP range of my particular VPC. So this is the first resource block for creating your VPC. Now we have seen how to set up the VPC and the Terraform code, but before we provision the VPC, there are two more components which we need to take a look. So one is public subnet and one is the private subnet. So why we need a public subnet and private subnet? So any resource which need a internet access or which can be accessed from an internet, that will reside inside our public subnet. And any resource which doesn't need an internet access and that can only be accessed from internally from public subnet, then that will go into our private subnet. So what's the example of our private subnet resources? So for example, databases. So databases are only accessed from our application. So our application will reside into our public subnet, and those will be able to communicate to our private subnet. So whenever you work with the networking, so you need to set up your public as well as the private subnet within the VPC. Let's take a look onto the public and the private subnet infrastructure code inside our networking module. So like we have previously seen the VPC code, so here you can see the subnet code also. So this is the block which I have created for creating the subnet, and this is going to be my public subnet. And similarly, this is going to be my private subnet. So here there are certain things which you need to keep in mind. So here this is the count. So here I have created a count because into the Terraform variables, if you'll see the value, then this is the public subnet IP range. So here I have specified the IP range which falls within the VPC IP range. So here you will see this is the 11.0.0.0, and here you will find the public subnet IP range is like 11.0.1.0, and here the second IP range for the second public subnet is the 11.0.2.0, and the subnets are for the providing the maximum availability. So this is the IP range which I am using for public subnet, and this is the IP range I am using it for the private subnet. And these values are in an array, or you can say a list, so which contains two IP ranges. So that's why if you go to the networking main.tf file once again, so this is the count is for that particular reason. So it will iterate on those values based on the public subnet and the private subnet IP ranges, and then it will just create those subnets. But as you have seen in the diagram, these subnets like the public subnet and the private subnet reside within the VPC. So we need to make a reference to our VPC. So first of all, here I have chosen the VPC ID. And that VPC ID, which you can see, this is the VPC which we have just created. So first we have created the VPC, then we are going to create a subnet, which is going to be a public subnet, but we need to make a reference that in which VPC it is going to be created. So here we are making a reference to that particular VPC ID. And here you will see the name, so which is pointing to the same VPC ID. All right. Now we know the VPC where it belongs, then we need to specify the IP range. So here you can see, here I'm iterating and fetching the value of my IP range for the public subnet. All right, then second, here is the availability zone over here. So here I'm passing the value. Since I'm working for Jenkins, I'll be working inside my Europe West region. So here I will be specifying the availability zone as a variable. So if you go to the main.tf, so from where we are sending the value. So here you can see the EU availability zone, and in the tf watts file, you will find the availability zone. Here you can see line number 7. So EU West 1A and EU West 1B. So these are the availability zone for my Jenkins. Now we have seen the public subnet code. Then let's take a look onto the private subnet code as well. So here the code is pretty much exactly similar. The only thing which I'm changing over here is the private subnet IP ranges, the IP range which I have assigned for my private subnet, and rest of the details are exactly same for my private subnet. Let's try to provision, or let's try to set up at least this infra, which includes VPC and the subnet. And here you will see there are other resources which I need to create, but I will, for the time being, I'll just comment out all those resources because we are just at the moment we are looking into VPC and the subnet. So I will just comment all this section over here. All right, so now in the networking, we are setting up the VPC and the subnet, and we have our rest of the code commented inside this particular GitHub repository. Also, before we proceed, there is also one more important thing which I need to show, which I would like to show to you, is the provider.tf. Since we are working with the AWS, so we have the provider section where I am using the region, which is like a West 1 region, and here I am using the credentials for my AWS account. So I have stored this credential at this particular location, which is my local macOS directory, which is like a user Rahul Wag and .aws. So I would highly recommend to create the AWS credential for your own AWS account. And if you don't know like how to create it, then just go to your AWS account over here, sign into console, and go to your root account, go to security credentials. And here, as you can see, I have created some access key for myself, and here you can also create a new access key for you, so that you will have an access key and the secret ID for your AWS account. And those you can store inside the credential file. That's the AWS credential file, which you can store it onto your local laptop, so that your Terraform code can use those credentials to provision the infrastructure. So that's a key important thing which you need to keep in mind. All right, so let's open the terminal, and here I'll just open the terminal. I'll just clear the screen. I have been working previously, so I'm just gonna increase a bit over here. I'll clear it once again and just check the path. So I'm into the Terraform Jenkins directory, which is correct. And then I would like to run the command like a Terraform init command. So Terraform init command is really essential to initialize your modules, as well as also download the AWS required dependencies so that Terraform can provision the infrastructure. So let's hit enter over here. And here you can see our Terraform has been initialized successfully. All right, so let's clear this screen. The next command which I need to run is the Terraform plan command, so that we know like how many resources we are going to provision. And here you can see it's saying me like 5 resources it is going to create, which include 1 VPC, 2 subnet, the 2 public subnet and the 2 private subnet, which equates to 5 resources. I'll clear the screen and I'll show you like this is my AWS account. Go to the home page, and we are provisioning this whole infra into the EU West region. I can show you one more slide. This is our target architecture into the different regions. So our Jenkins setup will reside into the EU West region, so that our infrastructure code or application infrastructure is separate from our Jenkins. So that's why I'm working into the EU West 1 availability region, and that's the availability zone I have set up while using the VPC and the subnet. So that's the key difference. So just keep in mind, we are right now working into the EU West 1 region. And since I have mentioned like EU West 1 region, so go to the drop down into the AWS console for availability zone or the region, and here you will find an option for the region that is EU West 1. So click on it. And here I'll zoom a bit over here. And if you go to the VPC section, then you will not find any VPC which I have yet not created. So go to the VPC. Here you can see this is the default VPC, but we need to create our own VPC over here. Let's run the Terraform apply command so that we can create those VPCs and subnets. So the command is Terraform apply. And it is asking, are you sure you want to create those resources? Type yes and hit enter. And here you can see it has created the 5 resources. So let's go back to our AWS console once again and refresh this page over here. And here you can see our first VPC has been created. And this is the VPC ID, which you can see over here. And the IP range, which you can see, that is 11.0.0.0. So that's the IP range which I have assigned. So we have verified the VPC. The next thing which we need to verify is the subnet. So again, go to the left navigation menu over here and go click on subnets over here. And here you can see there are 4 subnets which we have created, 2 public and 2 private subnet. So let's open the public subnet over here, and let's open one private subnet over here. So to verify the details. So here, first let's check the IP ranges. So here you can see the public subnet 11.0.1.0 and the private subnet should start from 11.0.3.0. So 3.0 is and 4.0 is for private subnet, and 1.0 and 2.0 is for public subnet. And also you can see the VPC. This is our private subnet, but this private subnet should come inside our VPC, which we have just created. So click on this VPC, and here you can see this is the VPC which we have just created. So this is the way you can verify your VPC and the subnets. Now, after creating the VPC and the subnet, the next resource which we need to create is the internet gateway. And we need to create an internet gateway for our public subnet so that any resource which we will be creating inside the public subnet will have access to the internet, and as well as anyone from outside world can access the resource present inside our public subnet through internet gateway. So let's jump to the code and I'll show you like how to create your internet gateway. So this is my Terraform Jenkins repository. Go to the networking and open the main.tf file, and again we need to enable few codes over here. So next resource which we have commented previously we need to enable is the internet gateway. So here I'll just enable the internet gateway and I'll comment the rest of the code. So this is the resource block which will be creating an internet gateway. And again, if you take a look onto this diagram, this internet gateway is still present inside this particular VPC. So here we will make a reference to the VPC ID so that we will be able to create the internet gateway within that particular VPC. So that VPC is there, and this is the name of my internet gateway. So let's create this internet gateway by using the Terraform plan and apply command. So go to terminal over here. I'll just clear the screen once again, then run the Terraform plan command. And here you can see it is planning to add a resource, one resource. I'll clear the screen once again and I'll run the Terraform apply, and I'll supply the auto approve so that I don't need to type yes over here. But in production, just try to be careful. Don't use auto approve flag. I'll hit enter, and it might take a minute or so to create an internet gateway. And here you can see our internet gateway has been created. So let's go back to our AWS console and click on this internet gateway on the left navigation menu inside our VPC section. So click over here, and here you can see our internet gateway has been created. And this is the internet gateway, and this is the VPC which it has been attached already. Moving ahead, the next resources which we need to create for this whole infrastructure is the route table, and we need to create a 2 route table, one for the public subnet and one is for our private subnet. So these are the route table which we will be creating, and for that let's go back to our IDE and here we are going to enable next line of code. So here you will see previously we have set up the internet gateway. The next thing which we need to set up is the route tables, and route tables we will be creating it for public subnet as well as for private subnet. So I'll first enable this code for route table, and this is going to be our public route table, and this is I'll show you like how to create our association. But let's first take a look. This is our route table for our public subnet. And if you go down here, then this is our route table for our private subnet. All right. And I'll just remove this code also. So I think that's it. All right. Okay, so this is the code for our public route table, and here you can see again we need to mention the VPC ID so that we create those route table within the VPC. So that's an important thing. Secondly, we need to create a internet gateway route, since as you have seen over here into the diagram, this route table is responsible for routing all the requests. So if anyone who is residing outside of this particular AWS environment, then that request will come, and that request will come via internet gateway, and this route table will be responsible for forwarding that request from internet gateway to our subnet. So we need to create a route for this internet gateway for our public subnet, but in private subnet we don't create an internet gateway. So here in this section of when we are creating a route table inside our Terraform, so I have created a section for a route, and here we need to specify the IP address, which means 0.0.0. That indicates that it is an internet request. So anyone from internet can access this particular resource. So whenever you specify this address, then you're making it quite open to internet. So that's the first thing. And this is the gateway ID. Since we have already created our internet gateway, which you can see over here, this is the internet gateway and this is the name of that particular resource, so which you will eventually find over here into the gateway ID. So if you click on this one, then you can see this is the same internet gateway it is pointing to. So here we have created a route table, we have assigned the VPC, and here we have created a route for internet, and here we have assigned the internet gateway ID to that particular route table. So that is going to be my public route table. So similarly, if you go to the private route table, then you will not find any internet gateway because we have not assigned any route, or we have not created any route between the internet gateway and our private subnet. So that's the key difference between the public and the private subnet and the route tables. Let's try to create the route table, and for the time being I'm just going to disable this association. I'll show you after creating our route table. So I'll just going to disable this association of our public route table as well as private route table. So I have disabled both of it. Go to terminal and I'll clear the screen, and I'm just going to run the command terraform apply auto approve. You can also run the terraform plan command, but since I have already know this code, so that's why I'm running the terraform apply with auto approve. And here you can see two resource added, which means we have created our route table, which is public and the private. Let's go back to our AWS console over here, and on the left navigation menu, click on the route table. And here you can see our private route table, and RT is for route table abbreviation, and this is our private and public route table. So let's click on this public route, private as well as public route table. So here you will find that this is the VPC, which it has been attached properly. Same over here, so it has been attached properly. But if you take a look onto the subnet association, then you will find it's completely empty. There are no subnet associated. Similarly, onto our public route table, if you go to subnet association, then you will find this is completely empty because we have not created any association. These route tables are still independent and not attached with any subnet. But for a public route table, you will find a route for internet gateway. So if you go to routes over here, then here you can see this is a route with the IP address 0.0.0.0 for internet, and this is the internet gateway. So if you click on this internet gateway, then it will point to the same internet gateway which we have just created previously. So this is our public route table with our route to the internet gateway, and this is our internet gateway. But similarly, if you go to our private route table, which is our private route table, so here you will not find any route. So go on route. So here you can see this is the default route. There is no There is no IP address like a 0.0.0.0 for internet, and there is no connection to target to our internet gateway. So that's how we create our route table. The next thing which we will do, we'll focus on the subnet association. So we will fill these entries over here. Okay, so let's go back to the code once again into the networking. So first of all, we are going to enable the association between the public route table and our public subnet. So I'm just going to enable this block of code over here, and here you can see this is the AWS route table association resource, and here we need to specify the subnet, and here you can see this is our public subnet by the name which we have previously created, and this is our route table which is our public route table, and which you can see over here. So this is the highlighted name for our private route table, and this is the private route table I'm using, and this is the association between our subnet. And similarly, if you go to our private route table, so association, then here you will find the association between our private route table and private subnet. So here it's the private route table, and this is our private subnet. Let's apply those changes. So go to terminal over here. I'll clear the screen and I will just run the Terraform apply auto approve. So it took a couple of minutes to create the association. So let's go back to our AWS console to verify the association. So this is our private route table. So I'm just going to refresh this section over here and go to subnet association. So here you can see our private subnet has been associated with our private route table. And similarly, if you go to our public route table and click on subnet association, so this was our previous one. So if I go over here and I just try to refresh this section, then go to subnet association, and here you can see our subnet has been associated properly. One thing over here, if you are interested in learning the AWS networking from the AWS console UI side without Terraform, and if it feels like very overwhelming at this point of a time, then just go and check my one session. I'll post the link into the description section where I have shown like how to create your whole networking in an easy way using the AWS console. So I would highly recommend to go and check those sections so that it will be easy to understand all these concepts. Let's move ahead with our project. Moving ahead, the next resource which I have highlighted over here is the net gateway. But since we are working into the public subnet, so we will not be creating a net gateway inside our AWS infra for Jenkins. And finally, we will be creating an EC2 instance where we will be installing the Jenkins inside our public subnet. But keep in mind that we have already set up our public subnet and private subnet, but since we will mostly work on our public subnet, so we will not be using private subnet that much for our Jenkins installation. But how the EC2 setup would look like? So here you can see this EC2 instance is again present inside the VPC and inside our public subnet. So first of all, whenever we create a EC2 instance, then we need to point to the correct VPC along with our proper subnet so that we can provision the EC2 instance inside our VPC or the networking which we have created so far. So let's jump back to our IDE and start looking into the EC2 code of our Terraform. Alright, so let's open the main.tf where we have mentioned our module. So as you have seen previously, we have created all the networking related module and we have provisioned all the infra related to networking. The next thing which we need to set up is our EC2 instance. And for creating an EC2 instance, there are certain things which we need to create beforehand. So the first thing is the security group. So here is the security group which we will be creating, and I'm just going to disable other modules over here. So there are certain security group which we need to enable. Security group are just firewalls for our Linux machine, which is in case our EC2 instance. So on a high level, whenever we create a security group, then it is we are just allowing and disallowing certain ports onto in our firewall. So on a high level, we will be enabling the port 443 for SSH. We will be enabling port 22 for doing the SSH into our EC2 instance, and also the port 8080 so that we can access the Jenkins running on our port 8080. Here you can see this is the module which I have created for security group, and this security group is responsible for enabling the port like a 22, 443, 8080 and the port 80. So if you go to the security group module over here under this Terraform Jenkins directory, there you will find a security group directory, and there is a main.tf file. So here I have created a couple of security group. In the first security group, I am just enabling the port 22 as an inbound rule, and then port 80, and then port 443. And the outgoing request, I'm allowing all the requests to go out from my EC2 instance. I'm not blocking any of the requests. And also there is a one more security group I'm enabling. It's for Jenkins on a port 8080. So here you can see this is an inbound request or inbound rule for port 8080. So these are the security groups which will be created once I will run the Terraform apply command. Let's open the terminal and run the Terraform apply command over here. So I'm just going to run Terraform apply auto approve, and it should take a couple of minutes or maybe even shorter to create those security group. And here you can see our security group has been created. Let's go back to our AWS console to verify that. I'm just going to close. I'll just go to the home page, and in the search box type EC2, go to EC2. And in the left navigation menu, you will find an option for a security group. So here you can see there are a couple of security groups, which is this one and this one. Although I have kept both the names same, that's one mistake, but it's not going to create any problem. We are just worried about the security group ID that should be different. So here you can see I'll open this security group and I will open this security group. So I will change the name later. Anyway, so this is the security group to allow port 8080. So if you go and check the inbound rule over here, then you will find that port range is 8080. So we are allowing the port 8080 on this security group for EC2 instance. And another security group rule, if you go over here, then here is the description, which you can see like SSH22 port 443. And although I have mentioned 8080, but 8080 we have already created over here. So I just need to rename this one also, and also the port 80. But here, if you check the inbound rules over here, then you will find the ports like 22, 80, and 443. So we are enabling these ports using this security group for our EC2 instance. Okay, let's take a look onto the diagram once again, and we are still not there yet. We are still not created any EC2 instance in Jenkins. So we are just completing the prerequisites which is needed to facilitate the Jenkins installation onto our EC2 machine. So now we are gonna see the EC2 Terraform code, how we can set up our EC2 instance, and also we can install the Jenkins at the same time. So let's go back to our code IDE over here. I'm just gonna close all the tabs over here, and I'll just open the man Terraform file again. So we have set up the networking, we have set up the security group, and the next thing is we are just gonna enable the Jenkins module, this one. And here I'm just gonna comment the other one, the load balancer and other modules. We are gonna see it later. So here, this is the Jenkins module, and here you can see the source is available under the Jenkins directory. So just go here and open the Jenkins directory as well. All right. So here are a couple of things which I'm forwarding to that particular module. First one is the AMI ID, which is like a machine ID. Here I'm using the Ubuntu. So I can show you that one also over here. So AMI ID. So this is the AMI ID which you generally get from your AWS console. So if you take a look over here onto browser, I'm just gonna open this one. So when you go to the EC2 dashboard, if you click on launch instances, and if you choose like this, then you will get an AMI ID. So I just copied this AMI ID from here. So you can just choose suitable operating system, Linux operating system, and just copy the AMI ID if you don't want to use the Ubuntu. And if you want to use the Ubuntu, then you can just continue with this same AMI ID. Okay, so that's about the AMI ID. Again, let's go back over here. The second is instance type. So I'm just going with the t2.medium because it's a Jenkins, and we will be creating a certain pipelines onto the Jenkins. So t2.micro, the small one, will not be sufficient enough. That's why I'm just going with the medium instance. Tag name, so it is just an optional thing. So just keep whatever tag name you want to associate with your EC2 instance. Public key. So this is important because whenever you're working with EC2, then you need to create a public and the private key for your EC2 instance so that you can later on SSH into your EC2 instance. So before I show you the remaining code of Terraform, let's create the public and the private key so that we can associate the public part of the key with our EC2 instance, and we can keep the private key with us. For generating the SSH key pair, the command which you need to use is SSH keygen, and this command can vary based on the what kind of operating system you are using. If you are using Windows, then just try to install this utility, and if you are using Mac OS or Linux, then this command will work by default. So I'm just going to run the SSH keygen command, and this will generate the private and the public key. So just hit enter, and it is going to say you that it is going to generate the key at this particular location. So I'm just going to copy this part, and I'm just going to rename this key a bit. So I'll just put over here. Sorry, I need to rerun it. I'll just clear it once again. So I'm just going to run the SSH keygen command once again, and I'm just going to paste this part, and I'm just going to rename the file. So I'll just put something like Jenkins demo. and hit enter. Do you like to associate any passphrase? So I'm just gonna keep empty, enter again, and now your keys has been generated. So what you need to do, you just need to run the command ls to verify the keys. So ls lart, and then go to the location. So the location is this part. This is the location where I have generated these keys. So copy this one and paste it over here, and here you will find the two keys, which is Jenkins demo, which is private one without any extension, and there is a public key, which is Jenkins demo .pub. Pub is for public key. So now you have the public key and the private key. What you need to do, you just need to copy the public key part from this public key over here. So here is the public key. So what you need to do, you just need to run the cat command, and again same path. I just need to retype the path. So here I'll just use home Ubuntu. It should be Rahul. No, it should be users and then Rahul and then .ssh and then Jenkins demo, and then I'll just use pub for public key. So here you can see this is the content. You just copy this content from here, and then you just need to go back to your Terraform code, and here you need to paste the content of our public key. So here I have already created a variable for that public key. So if you go to Terraform wars file, and if I wrap this code so that you can see the complete key over here. So here you can see this is the public key which I have already created and pasted over here. So just paste that public key content over here, and this is the public key variable. And if you take a look once again, so this is the content which you will see a quite similar one. All right, so this is the public key part which you need to paste inside this variable for your own use. Remember, if you'll clone this repository, then this public key will not work for you. You need to replace this key with your own public key. All right, so I'm assuming that you have replaced this key, and again go back over here, and here you can see the public key will be associated with your EC2 instance. And remember that private key is still with you. So this is the private key which is residing locally onto your laptop. So we'll use this key later on to SSH into that EC2 machine. All right, but for this particular demo, I'm using this set of key. This is the key which I have generated previously. So this key which I'm associating over here, which you can see over here. So this is the public key which I'm associating over here. And later on when I'll SSH, so I'll use this particular key, AWS EC2 Terraform. So these are the key which I generally use for my own purpose, but I have shown you like how to create the keys for yourself also. All right, so let's go back there again, and subnet. So again, if you take a look onto the diagram, so this EC2 instance is present inside our public subnet, which you can see over here. So we need to supply the public subnet ID over here. So again, here is a subnet variable which I have created, and here I need to provide the subnets. So the subnets which I'll be providing is the public subnet. So here, since we have created two public subnets, so I'll be providing only one subnet, because we can create an EC2 instance into one subnet. So that's why I am fetching the 0. I'm putting the 0 over here so that I can get the whatever first in the list, the public subnet, I'll just create it over there. So that's a subnet. Then the security group. As you remember, I have just mentioned you that we have created a 2 security group, and those security group we will be associating with our EC2 instance. So here, this is the security group variable, and here you will first specify the security group from module. So if you go to the security group module over here, then this is the one. So here, this is the first security group module from where we will be fetching this one. So copy this and you will find it over there. So yeah, here it is. This is the first one, but I can show you this is from output actually. So this is the first security group which I have created, and this is the output where I'm just using the ID of it. So this variable will be responsible for outputting the ID of this particular security group, and this output variable will be responsible for outputting the security group ID of port 8080. So these two output variables I'll be using over here. So here you can see this first one and this is the second one. So I'm just passing both the security group to my Jenkins EC2 instances. So that's another one. Enable public IP address. So I just wanted to enable the public IP address because I'm just setting this EC2 instance into public subnet. So as you can see over here, into the public subnet. So we need to have the public IP of this EC2 instance. Okay, that's done. And then the last part is where we will be installing the Jenkins. So all these things till now, we are just setting the EC2 machine. That's it. And that EC2 machine is just blank. There is nothing on it apart from the security groups. So here, this is the Jenkins installation script, which we will be installing using the user data. And if you don't know like what is the user data in AWS EC2, then I will just, I have already uploaded a video on explaining like how to work with the user data. So you can install certain packages onto your EC2 machine. So we are using the same user data concept over here. And here I'm supplying this particular installation script for installing the Jenkins. So I'm just going to show you this installation script of Jenkins to you as well. So yeah, these are the parameters which is needed to create an EC2 machine so that it can install the Jenkins along with the proper subnet and the security groups. Let's take a look onto the Jenkins installation script. So here I have uploaded that script inside the Jenkins runner script directory. So here left hand side you will find the Jenkins runner script directory, and here you will find the installation script. So first of all, it's just a bash script, very simple. And here I'll just explain one by one. So first of all, this is the syntax which is needed for a bash script to work. Here I'm updating the package manager so that my operating system is up to date with all the latest information on latest packages which is available for that Ubuntu. After that, I'm just installing the JDK 11 because JDK 11 is necessary to install the Jenkins. So that's the first requirement. After installing, I'm just sleeping 30 seconds. So I'm just waiting for 30 seconds so that my JDK installation finishes properly. After that, these are the instructions which I have copied from the Jenkins official installation guide. So if you go to browser over here, and if you click on Google and type Jenkins installation on Ubuntu, then you will find a link, this first link, and if you go down over here, then these are the instructions for installing the Jenkins. So I just copied these instructions from here and pasted inside my this installation script. So here it is just doing the Jenkins package updation, and then after that it is updating the package manager, and then here it is going to install the Jenkins. And after installing the Jenkins, again I need to wait for a little 30 or 60 seconds so that the Jenkins is installed properly and so that it can start the Jenkins services. So that's where I'm just stopping it over here. So these are the part where we will do the JDK 11 and Jenkins installation. And once we have installed the Jenkins, then also we need to install the Terraform onto that EC2 machine so that we can provision the other infra that I'll show you later. But from here, these lines of code 15, 16, 17 and 18 will be responsible for installing the Terraform onto my EC2 machine. So once the EC2 machine is up and running, then we will see Jenkins running over there, and we'll also have a Terraform also installed over there along with our JDK 11. And I would like to show you the Jenkins module code also. So in here the Jenkins directory, here is the main.tf file. And these are the output variable which is necessary, which we will use it later. But here is the AWS instance. Here is the Jenkins EC2 instance. Here is the AMI ID which we have passed. Here is the t2.medium. This is the tag description which we have provided. This is the key which I have mentioned that I will be using my own key. This is a private key which I have just shown to you, which is this one. So this is the key which I'll be using. And the subnet which I have already passed, the Jenkins, the public IP, and these are the some option metadata option which we need to set it over there for my EC2 machine. And this is the key pair where I'll be passing the public key to my EC2 instance. So this public key which we are passing it from here, which you can see, this is the public key which we are passing it to our EC2 instance. Let's run the Terraform apply command to provision our EC2 instance with our Jenkins. So go to terminal over here. I'm just going to clear the screen over here, and I'm just going to run the Terraform apply. And it might take a couple of minutes or more because we are setting up EC2 instance along with the Jenkins, and it might take 2 or 3 or 4 minutes to come up the Jenkins, and we can verify the Jenkins later. So after a couple of minutes, so my EC2 instance has been provisioned, as you can see over here. And if you go back to my EC2 dashboard, I'm just going to refresh it over here, and here you can see our EC2 instance is running. Click on this instances, and here you will find the instance ID, and this is the description which I have mentioned for my instance. So click on it, and this is the public IP address. So just copy this public IP address, and remember, we have not set up any load balancer, any domain yet. We need to set it up later. So let's just verify the Jenkins installation first of all by using the IP address. So I'm just going to copy this one, paste it over here, and I'm just going to suffix it with the port 8080 and hit enter. And here you can see our Jenkins has been installed. So now we need to set up our Jenkins. So Jenkins is up and running, and then we need to set up our own username and password. And here you can see it is prompting us that your initial password at present at this particular location, which is this one, var lib Jenkins secret and initial admin password. So for that, we need to SSH into our EC2 machine, go to this particular directory, copy that password, and then we can reset our password. So for that, I'll open the terminal. I'll just go back to my terminal over here. I'm just going to clear everything, and as I mentioned, I'll just go to the SSH directory where I have already created my keys. So if I run the lslart, so here you can see this is the key which I have already generated. This is a private key, so I'm just going to use the same key to SSH into my machine. So how to SSH? So for that, what you need to do, I'll just increase the size of this screen so that it's easy for you to view the content. I think that's good. All right. So to SSH into this machine, what you need to do, you just need to click on connect over here, and here you will find the option for SSH. So just copy this command, and remember, once you generate the key, you also need to change the mode of that particular key. So just try to run the chmod 400 command onto that particular key, whatever key it is, whether it's without PAM extension or with PAM extension. Otherwise, you will not be able to SSH. So here I can show that one also. It's already there. So here you can see it has only the read-only permission. If you can see, this is the read-only permission. If it has a read, write, and executable, then you will not be able to SSH. So just keep in mind to run this particular command first of all to change the mode to read only. Okay, so I'm just going to copy this SSH command, go to my directory. I'll just clear this, and remember, I'm into this SSH directory and key is available into the same directory. So just keep in mind. So here, and the key is without .pam extension. So I'm just going to remove this one and just hit enter and type yes, or you want to connect? Yes, I just want to connect it. And here you can see we are now into our EC2 instance. I'll just clear it, and again go back to the our initial screen. Sorry, I just clicked on that link, but here this is the path for my initial password. So just copy this path. I'll copy it from here, go to my path cat and run the command, hit enter. You need to suffix it with the sudo. And here you can see this is our initial password. So I'm just going to copy this password from here, paste it over here, click on continue, install suggested plugin. So select this one, and it might take 1 or 2 minutes to install all the suggested plugins. So I'll be back when all the plugins are installed. After all the plugins has been installed, then we need to create our admin user. So here I'm just going to enter the name. So I'm just going to enter username Rahul. This is just for demo purpose. That's why I'm using the simple username and simple password. But for you, just try to keep the strong password and good username. And the name I'm just going to put Rahul Wag, and the email address I'm just going to put my own email ID, and then save and continue. Yeah, Jenkins URL, we can keep it, or otherwise we can already change it. We are going to set up this whole domain later, but let's just keep it. Just keep the way it is right now. Save and finish. Start using Jenkins. And here you can see our Jenkins is up and running, but still we need to configure our domain, which is jenkins.jhook.org. So if you take a look onto the diagram, then I'm talking about this particular URL, which you can see, which is from user. So jenkins.jhook.org, which will go to Route 53, then it will go to load balancer, and then it will go to our EC2 instance. Right now we are just accessing directly this EC2 instance using the IP address. All right, so let's take a look onto the diagram once again, and here you can see this is the complete Jenkins setup which we are trying to achieve. And now the next component which I'm talking about is this particular load balancer. So we need to set up our load balancer so that we can point our domain to this particular load balancer using the Route 53. So let's go back to our IDE and start setting up our load balancer. So here, this is my ID. I'll close all the tabs over here and I'll just go to main.tf and I'll just take a look. So now we have seen the networking, we have seen the security group, we have seen the Jenkins, we have installed the Jenkins, and the next thing is the load balancer target group. So here, this is not a load balancer yet. We need to create a group. So load balancer target group. So target group is like a group of EC2 instances. So we'll create a group. In that group, we will attach multiple, we can attach multiple EC2 instances. So we are just going to create this logical target group using Terraform so that we can later on use that group inside our load balancer. So let's take a look onto this module again. So here I'm just going to disable the load balancer module as of now. So here, this is the code where my load balancer target group module exists. So here, if you go into the left navigation, so here is the load balancer target group. Open the main.tf over here. But let's take a look onto the parameter first. So first of all, this is the path which I have just shown to you. This is the name of my target group. So yeah, this is the Jenkins load balancer target group. Load balancer, we are going to create it later. So target group port. So as you have seen, my Jenkins is running on a port 8080. So here you can see this is the port which is 8080. So that's why I'm just using the port 8080 over here. The protocol which I'm going to use is HTTP for my target group. The VPC ID, again, everything we are working within the VPC. So here you can see this, we will be working in the target group within the VPC. Load balancer, we'll set it up later, but the target group will be still inside our VPC. Okay, so here is the VPC for that particular target group, and this is the instance ID. So as I have told you, this target group can contain multiple EC2 instances. So here we need to pass the EC2 instance into that target group. So yeah, this is the EC2 instance, which you can see. I think I can show you like this is the Jenkins, go to main. And here is the output variable, Jenkins EC2 instance IP. So this is the instance IP. I'm using it over here. So if you go over here, so here you can see Control F and here. So I'm just passing this instance ID. So this will create a target group for that particular EC2 instance. And I can show you the code also. So here in the main, this is the code for target group. Here is the name, here is the port, here is the protocol which I have just shown you, here is the VPC ID, and here is the health check for that particular Jenkins. So I'll be using the endpoint URL, that is login, and after the port 8080 where the login URL is accessible. So this is the health checkpoint. So the target group treats that particular endpoint as a healthy, and it can attach to the load balancer. So this is the code for target group. So go to terminal. I'll clear the screen over here and then just run Terraform apply, and yeah, just wait for a minute or so. And I'll be back once this target group has been created. So as you can see, our target group has been created. So let's go back to our AWS console. I'll go over here. I'll go to the home page, and here in the search box, type EC2, click on this EC2 over here. And in the left navigation, go to the load balancing, and here you will find the option for a target group. So click on target group, and here you can see Jenkins LB target group, which I have just shown to you. Click on it, and this target group will contain an EC2 instance which is running. So here you can see this is the instance ID which I can open here in the new tab, and here you can see this is the instance ID. Just copy this and copy this IP address, and which I have already shown to you. Maybe I can again show to you that this is running 8080. So here you can see the Jenkins is running. So yeah, so this is the target group, and this is the instance ID included into that target group. So I'm just going to refresh this page once again. And the health status is unused. So this target group is up and running. Now we need to provision our load balancer so that our load balancer can point to this particular target group. All right, so now I'm talking about this particular load balancer, and this load balancer will point to the target group which I have just shown, and that target group will point to this EC2 instance. So that's how the request is flowing. Okay, so again, go back to IDE. I'm just going to minimize this one. Go to our main.tf. I'll close everything over here. Close all tab. Go to main.tf, and now we are going to enable the application load balancer module. This one, and I'm just gonna enable only this section. Okay. Certificate manager, that's also needed. So anyway, I'm just gonna enable this one. I need to enable all the three modules because there is a dependency between all of it. So this is a load balancer module first of all. So I'm just going to explain this part first of all. So here's the code for load balancer. If you go over here into the load balancer, then here you will find the code for load balancer. So I'll explain from the parameter, that will be easy for you. So the load balancer name is this one, which is I'm passing over here. Is it an external load balancer? No, it is not an external load balancer. That's why it's false. Load balancer type is application because we are deploying it on an EC2 instance. So that's why I kept it as an application. Security group for our load balancer. The security group should also have the similar security group which we have configured onto our EC2 machine. So here I'm just using the same security group which we have just configured. So here you can see the same security group for SG, SSH and HTTP. So these are the same security group I'm using. So I have configured the same security group for my load balancer. Subnet IDs. So here I need to provide the subnet. So again, my EC2 instance, if you can see over here, it's into the public subnet. So here I have specified the public subnet for my load balancer. Tag name, it's optional. Just keep whatever you want to keep. Target group. So again, key point. So here we have created this target group. So we need to use the same target group over here into this. So if you go to the target group module, which is this one, so here I have created an output variable, which is this one. So this will print out the ARN of this particular target group. So this is the value. I'm copying it over here, and here I'm pasting into my ARN, target group ARN. So here we need to attach, here I'm attaching the target group to my load balancer, so that load balancer can know which target group it is going to forward the request. Then again, the instance ID, we also need to specify the instance ID of my EC2 machine. So here, this is the instance ID from modules Jenkins. So if you go to Jenkins main.tf, then here you will find the Jenkins EC2 instance IP. So that's there. And listener port, the port is 80, protocol is HTTP, and the default action is forward. Yes, I want to forward the request to that. And the 443 is for HTTPS because we will be setting up two listeners for our load balancer. One is on HTTP and one is on HTTPS. So that's a difference between those two. And then the certificate manager. So as I told you, like as I have shown in the diagram might be previously to you. So if you go to this diagram over here, so this is route 53 and this is how the request flow will happen, which I'll show you. So here, this URL will have a HTTPS. So whenever someone will access this URL, then this request will land on route 53 and route 53 will forward it to application balancer and then it will go to EC2 machine. Application load balancer will forward it to target group and target group will send it to EC2. So for this HTTPS, we need a certificate manager. So for that, we have created a certificate manager, and for creating a certificate manager, you need a hosted zone. Okay, so load balancer part is over now, but now we are talking about the hosted zone. So load balancer, these many parameters are sufficient enough for you to create a load balancer. That I'm going to show you, but let's talk about a hosted zone also. So here, if you go to the home page and if you type here route 53, this is an important concept if you are managing the domains and if you're pointing the external domain to our AWS. So here is the hosted zone. So here, this is the domain which I have already purchased for myself. So if you click on it, then this is the domain which I have already purchased. So whenever you purchase a domain which is external, or whether it's from AWS, so you can purchase a domain from AWS, or also you can purchase it from other services like GoDaddy, Namecheap, SiteGround, whatever. And also Google domain is also there because I have bought this domain from a Google domain. So this is the hosted zone over here, and this hosted zone I have created for a domain jhook.org. So let's say, for example, you already purchased a domain and you need to point that domain to this hosted zone. So you need to create a hosted zone first of all. So go on create hosted zone, and here you need to type the name, not type the name. So let's assume that you have a test XYZ. So you'll just enter the name and create a public hosted zone and then click on create a hosted zone. And here you will see there will be two hosted zone as you can see. So this hosted zone I have already created, so that's why it is there. But this test XYZ I have just created, although I don't own the domain, but I just wanted to show you the process how you will work with it. So create a hosted zone based on the exact domain name which you have with you. So here, once you create it, then you will get these records, which is a name server records for you. So now this is the text XYZ. I'm assuming you will have your own domain. You will create your own hosted zone. So similarly, if you compare with my jhook org, then you will also find the same thing. So I just wanted to show you that there is nothing superficial I have done over here. I have just created a hosted zone, and these are the name server settings which I'll be using later. So to work with this whole setup, we need to set up this Route 53, and in Route 53, we first need to set up our hosted zone. So we have set it up the hosted zone just now. So I have already explained the application load balancer part to you, but here's the hosted zone. I know it's a bit complicated, but it will not be that complicated once you understand the whole flow. So this is a load balancer all the way. This is the code for load balancer, which will set up our load balancer. And this is the hosted zone. So let's take a look onto the hosted zone also. So here's the hosted zone module. Go to main.tf, and here I have already created a data block. So why do we need a data block? So hosted zone, I'm not provisioning with Terraform. I will create a hosted zone manually using the AWS console, which I have just shown to you, like how I have created for test XYZ. So here, these data block we will use for any existing resource on AWS. So this is the jhook.org hosted zone, which I have already created. So that's there. Then we need to create a record. A record is just a redirection record. So whenever we create a hosted zone, and inside that hosted zone, we will create a record, and a record will point to the load balancer. I can show you that flow also. So here's how it works. So if a user enters a URL, so let's say user enters jhook.org or jenkins.jhook.org, then that request will land on our hosted zone. Then hosted zone, which is our jhook.org, and then it will check for the entries. So here the default entries are these ones, like a name server and SOA entry, which are default one whenever you create a new hosted zone. But in case if you create a record over here, these are the name server record, which you can see over here. But inside that, when you create a record, then this a record is responsible for redirecting the domain request, which is like a www.jhook.org, to our EC2 instance. So here you can see this is the a record with the IP. But in our case, instead of IP, we will be using a load balancer. So if someone enters www.jenkins.jhook.org, then request will land on our hosted zone, and then it will try to find the a record. So a record, you will find the record, and here you will find the URL of our load balancer, so that request will forward it to our load balancer. So that's the significance of this particular hosted zone. So if you take a look onto this flow again, so here is the existing hosted zone. This is the record, which is the a record we are trying to create. And here we are just trying to pass the load balancer name. So here you can see the aliases which we have created over here. And here we are passing the load balancer DNS name and load balancer zone ID, where my load balancer DNS exists, from which zone, and this is the DNS name of my load balancer, so that this a record should be created for my load balancer. I'll show you once we provision this one. Okay, so let's go back to our main.tf file. So this is about hosted zone, how it's working, and then this is the certificate manager. So hosted zone will just enable you the HTTP request, but it will not enable you the HTTPS request. So for that, we will use the certificate manager, and that we need to issue the certificate for each domain. So here our domain will be jenkins.jhook.org. It will not be jhook.org, but it will be a subdomain, jenkins.jhook.org. So whatever subdomain or how many number of subdomains you create, you need to issue the certificate for that particular subdomain or n number of domains. So here I'm using this one. So I can show you this one also into the certificate manager. Go to main.tf, and here you can see this is the resource which will create our certificate, and then after that, here is the record for that certificate. That record I'll show you, because once the certificate is issued, then those records also need to be inserted into our hosted zone. So here in this jhook.org, right now there is no a record. So once we will provision our load balancer along with our hosted zone, then you will see a record with the load balancer, and you will also see a record with our ACM, which is our application AWS certificate manager. So those records will get inserted over here. Okay, and here, yeah, these are the validation, and here it also runs the validation because AWS will try to verify whether I own that domain or not. So that's the key thing which you need to keep in mind. Okay, all right. So there is also one point which I would like to mention about the domain settings. So if I can show you one more slide and flow to you, which is this one. So right now I have bought this domain from a Google domain, and now we are trying to set up our hosted zone into jhook.org. So what happens is, like, when you create a hosted zone, then you get a new name server setting, which is this one. These are the name server setting from AWS, which I can show you over here. Here you can see NS652 AWS DNS 17, and which is exactly same over here. Here you can see. So these are the name server which is created, say name server records which has been created by AWS. But I already bought this domain from Google domain jhook.org. So these also issue some DNS name server record from Google. But since we are working on AWS, so what we need to do, we just don't need to use this name server record. But instead we need to use the name server records from our AWS and put it into my Google domain. And so that when someone enters jhook.org, or whether he enters jenkins.jhook.org, so any subdomain which belongs to this parent domain will always point to this name server records. So instead of using Google's name server record, we will be pointing to our own name server records from AWS. Also, I can show that part before provision load balancer and the hosted zones certificates. So I'll go to Google, and here I'll type Google domain, go to Google domains, go to manage domains. And here you will find the domains which I own. So click on jhook.org and go to DNS. And here you will find a managed name server. So managed name server, click on it, or maybe here you can see the server. So here you can see this is NS652 AWS DNS 17. So I have just manually configured these name server setting, which I got from here. So this is how the redirection is happening all the way. So request is going to the jenkins.jhook.org. From there it is finding the records, which is like this. So here jhook.org, so here it is finding the records of name servers of AWS, and then it is going landing on our Route 53. So that's how the request is flowing. Okay, so that's being said, let's go to terminal. I'll clear the screen over here, and then just I'll check whether I have enabled all the modules or not. Yeah, so I have pretty much enabled everything now. So now we should be able to access our Jenkins using this URL, which is jenkins.jhook.org instead of IP address. All right, let's run the apply. And it might take 3-4 minutes because it's a long process, because it will create certificate, load balancer, and then it is trying to validate my domain as well. So just be patient with this one. Sorry to interrupt you in the middle of this particular session, but I have seen like many of you really enjoy this kind of a content, but you don't consider subscribing to this channel. So this is a one small request from my side. If you really like this kind of a content, then please consider subscribing to this channel, because this will help you to grow my channel and to produce similar content in future. So here's the request from my side. Just click like this video, and also click on the subscribe button. I would really highly appreciate that one. Thank you. All right, so as you can see, my load balancer has been provisioned, my Route 53 A records has been created, my certificate has been issued. So let's verify all the details one by one. So I'll go to my load balancer first of all. So I'll just open the tab, and here you can see I have not refreshed this Route 53 page yet. So I'll refresh it a bit later once we verify all those load balancer detail. So here, go to EC2, click on EC2, and the left navigation menu, click on load balancer, click on, this is the load balancer which we have provisioned, and here you will find the load balancer details. So here you can see the HTTPS and HTTP listener for our Jenkins application. All right, but just copy this DNS name from here and paste it over here. So this is the IP address through which we have accessed the Jenkins, but I'm just gonna remove it and put it over here. So here you can see we are still able to access the Jenkins using the load balancer DNS name. but we still don't want to use the load balancer DNS name. We want to use the our own subdomain for that one. But anyway, we are able to verify our domain, the load balancer. The next thing is we need to verify our Route 53. So here, this was the page. So I'm just going to refresh this page over here, and you will see the couple of entries over here. So here you can see this is the first A record for that one, and this A record is pointing to my load balancer. So here you can see this is the load balancer URL which I have just verified. I can show you once again. I'll just close this one, I'll close this one, I'll close this one also. So I'll paste it over here, and here you can see this is our Jenkins page using the load balancer. But we already created the A record for our subdomain. So that's already exists. So just copy this subdomain now, and I'll open it into incognito mode and hit enter. And here you can see we are able to access the Jenkins. So now we are able to access the Jenkins using the subdomain. And here you can put the password. And here you can see this is the home page of my Jenkins. Okay, that's been done. And also there is one more thing I need to verify here is the ACM, which is like a certificate manager. So click on here, and here you can see we have issued the certificate for our domain, which is jenkins.jhook.com. and if you click on it, and here you can see the status is issued and the records has been created. Here you can see the CNAME, and these are the records which has been created into Route 53. So if you go to Route 53 and go to hosted zone and go to jhook.org, and here you will just Control F and try to find it. I think yeah, but anyway, here it is. I think, yeah, there it is. This is the record for that particular CNAME. Here it is. Okay, so I think we are now able to access it. I'll just try to re-access it. Jenkins.jhook.org, and yeah, it's working. I'll just type the username and password, and that's been done. So now we are able to finish our first part where we have only set up the Jenkins, which is running on our EU West region. And now we will start setting up our pipeline for our actual application, which is our Python Flask application, which will be running into EU Central region. So let's take a look onto the second part now. Now I'm talking about my second repository where I have my infrastructure code for my Python Flask application. So this is the GitHub repository where my whole project exists for AWS infra using Terraform. So here in this project, in this Git repository, actually I have created a Jenkins file for setting up my whole pipeline. So if you take a look over here, then from this particular GitHub repository, we will use a Jenkins file. So here you can see one Jenkins files at the bottom. I'll show you the GitHub repository very soon. So we are going to use this Jenkins file, and with the help of this Jenkins file, we are just going to create our pipeline in Jenkins, and that pipeline will execute the command terraform init, plan, and apply. And once we execute that commands inside on using the Jenkins file, then it will provision the whole infra for us. And the infra I'm talking about is this whole infra where we'll set up the VPC, where we'll set up the subnet, which is like a public subnet, and the private subnet, internet gateway, route table, EC2 instance, REST API application using Python, and then RDS instance with a MySQL. So this whole infra we are just gonna set up using the our Jenkins pipeline, and that Jenkins pipeline will only issue the terraform init, plan, and apply command. So let's take a look onto this GitHub repository and try to look into the components which we will be using over there. And this is the code repository for my DevOps project. And this is the code repository which contains the infra, which is responsible for setting up the whole networking, which again includes the same VPC, subnet, private subnet, public subnet, internet gateway, route table, and then your Route 53 application load balancer, and then pointing our main domain, which is jhook.org, to our application. So here you can see these are the different module, which is like a EC2 module, certificate manager, which we have just seen. Then we have a hosted zone, load balancer, target group, load balancer, networking, RDS, our S3 for storing the remote state file, and then the security group, and finally the main.tf, where we will be writing our own modules along with all the infra. So here let's take a look onto the flow of this particular whole project, the DevOps project. So here this is the main.tf file, and again the project structure is exactly same, just like a Jenkins. So here again it's a networking section where we'll be setting up our VPC, public subnet and private subnet, and I'm just not gonna repeat those things again over here because this is going to be the exactly same. Again, the security group for my particular EC2 instance, here I'm just gonna change the port. Previously it was running on a port 8080, but this time it will be running on a port 5000 because we are using the Flask API. A Python Flask API which runs on port 5000. This is the EC2 machine, and here EC2 machine again the same AMI ID. The instance type is t2.micro, tag name, public key. Again, I have already shown you like how to create your public and private key. The subnet, again I'm putting it into public subnet because our application will reside onto the public subnet. If you take a look onto this diagram once again, so here you can see this is our public subnet and this is our private subnet. So database will be into our private subnet, but this EC2 instance with our Python application will be into public subnet. So that's why this EC2 instance is belonging to my public subnet over here. Again, the security group which I need to enable, which will include the port 80443, our 5000 port. So these are the essential port which we need to enable for our EC2 instance. And also if you go further, then here we need to enable the port 5000. So this is the first security group, this is the second security group I have specified over here. Enable the public IP. So yes, you need to set the public IP address for your EC2 machine for your Python application. And then here is the user data for installing the Apache. Not Apache, I need to rename this particular file. I have just put the wrong name over here. But this is the user data section where we'll be running some installation script for my EC2 instance. Let's take a look onto this particular installation script file so that you know like what it's gonna do once we start provisioning our EC2 instance. So here go to the template, and remember the naming is little incorrect over here. I need to rename this particular file. So it should be like a EC2 Python application.sh. So just a side note for you. All right. So as I told you, like we will be installing our Python application, or we will be running our Python application inside our EC2 instance. So this is the script for that. So first of all, we'll switch to the directory like a home Ubuntu after installing or after provisioning our EC2 instance. Then I'll running the update. I'll update the package manager. Then I'll install the Python inside my EC2 machine. After installing the Python, I'm just gonna clone my project repository. So here's the key thing. So I had told you we will be working with the 3 GitHub repositories. So this GitHub repository is only responsible for provisioning the infra for my Python application. So here you can see this is the infra code, and there is a one more GitHub repository which I have already created. So that's with the name Python MySQL DB project. So this is the another repository which we will be cloning inside our EC2 instance, and then we will be running that application. So if you go to this particular repository, which you can see over here, there is a app.py, and where it contains all the REST APIs which I have implemented. So here you can see this is the health endpoint to show that our application is up and running. This is a create. This REST API are pretty simple. I just leave it to you like how you wanna build the REST API, because once your application is up and running and it is connected to database, then you can start implementing your own business logic to it. So here's the first REST endpoint to create a table inside my MySQL DB. Then this is the REST endpoint for inserting a record, and here this is the REST endpoint for fetching the record, and this is just a default route for index.html, so that our whenever I try to access our API using the jhook.org, then it will land onto the index.html page of my home page. So yeah, this is the API which we will try to clone inside our EC2 instance. So here you can see this is the here I'm just switching it to my work directory. Then I'm updating the package manager, installing the Python, I'm cloning my GitHub repository, then I'm waiting for 20 seconds over here. Then after cloning, then I'll switch to my project directory, which is like a Python MySQL DB project one. And after that, I'll run the pip install requirement.txt so that I can install all the Python libraries. And after that, I'll just wait for a 30 second, and then I'll just try to start my Python application using the Python 3 app.py in the background mode. And then again, I'll try to wait for a 30 seconds so that my application is up and running on a port 5000 of my EC2 instance. Moving ahead, I'll just go to main.tf file once again. So again, the load balancer, it's exactly the same which we have set up into our EC2 instance for our Jenkins. Only the difference is the port. Here I'm using the 5000 because I'm running my application on a 5000 port. So that's the basic difference between these. Again, the application load balancer, here you will find again exactly same module, same everything. The port is different over here, which is 5000 for HTTP and rest is for HTTPS for 443. And again, here you will find a certificate manager, hosted zone. So hosted zone, I'm using the domain name for jhook.org. Here I'm using the main domain. I'm not using a subdomain over here. So that's the key difference between the old EC2 instance Jenkins setup and this setup. And here again, the certificate manager to issue the certificate for my main domain, which is jhook.org. So these are the hosted zone settings, and also you will find the variables over here. So here you will find the details about the variables which I'm passing. So my VPC for this Jenkins, not Jenkins, but for my Python application is 10.0.0.0. The public IP ranges are 10.0, 1.0 and 10.0, 2.0, and for private it is 10.0 and 3.0 and 10.0, 4.0. Availability zone is EU Central 1A and EU Central 1B, but remember Jenkins was into West region. This is the public key which I have shown you, like how to generate those public key and put the public key here and keep the private key with you. This is the AMI ID for my EC2 instance, and this is the main domain name which I'll be using, which is jhook.org. This variable is just empty. I can just remove this later. All right, and also this bucket which you can see over here, this bucket I have already created manually so that we can store our remote state of my Terraform. So which I can show you if we go to our AWS console over here. I think I forgot to mention into the Jenkins setup, but just keep in mind these buckets I have created manually because this is going to store the remote state of my Terraform. So click on S3 over here. And here you will find a couple of buckets. So here you can see this is the bucket for Jenkins and this is the remote bucket for my Python project. So these are the buckets which I have created manually using the console, and these will store the remote state of my Terraform. So that's one more point which I forgot to mention earlier. All right, and yeah, let's get back to main.tf once again. And here, this is the RDS instance. So this is a new instance or new module which we are trying to provision inside this Python application. So here, the source of the code is here. So here you can see this is the module code, which is main.tf for my RDS instance. And if you take a look over here, the allocation storage is 10 gigs. Storage type is GP2, engine is MySQL, engine version is 5.7, instance class is t2.micro I'm using for database. Identifier, I'll pass it from the module from where I'm calling it. So now I can show you the actual module parameter from here. So here you can see this is the name of my subnet group, and this is the subnet group which I have created. So subnet group, because this is a RDS instance and this RDS instance is going to be created into our private subnet. And to assign the private subnet to RDS instance, we need to create a subnet group. So here I have just created a subnet group, and inside that subnet group, I'm just trying to pass my subnet ID over here. And also there is a MySQL security group ID because we need to enable the security group for that RDS instance, because MySQL port is a bit different over here. I'll show you in the security group section. So probably in the security group, if you go to main.tf, then you will find a security group. Here it is, security group. So here the security group which I have created it for my RDS instance, which is 3306. So that's the security group I'm trying to pass over here, and the identifier is mydb, username is dbuser, password is db password, and db project dev project db. So that's the db name for it. Although there is a one security a fallback over here, because I'm hard coding the password for demo purpose, but in actually we don't hard code those password. We just use some secret manager to store these password. So that's just a side note for you. Since I'm doing it for the demo purpose, so I just tried to keep it hard coded over here, because I'm just going to destroy the whole environment after the demo. So that's a one point, just keep in mind. Okay, so this is the actual flow right now. So we have just gone through all the modules for our project. We have seen the Python code of our REST API, and now we need to set up our Jenkins pipeline, and it is going to provision this whole infra for us along with our domains, which is pointing to our REST API. So let's go back to our Jenkins and start setting up our pipeline. So I'll just open the browser over here, and I'll open a new tab, and here I'm just going to type jenkins.jhook.org, and here I need to enter the name. So I'll just use the name and password. I don't want to save it. And also, before we create a Jenkins pipeline, so just one more point. So this Jenkins will not be able to communicate with our Europe Central region, because we need to provide the credentials for our AWS. So for that, what we need to do, we need to download one plugin so that we can create our AWS credential inside our Jenkins. So go to Manage Jenkins first of all. And here we need to click on plugins, click on plugins over here, go to available plugins, here type AWS steps, and here we need to install this AWS steps plugin. Click on install, and here you can see it's pending. It will install all the plugins soon for AWS steps. All right, so all the plugins for my AWS pipeline steps has been installed, and I can go back to my Jenkins over here. Again, go to Manage Jenkins, because we need to store those credentials for my AWS. So here you will find a credential section. Into Manage Jenkins, go to System, go to Global Credential, and here click on Add Credentials over here. And here in the kind, you will find an option for AWS credential, and this option will enable after we install the plugin which we had just did a couple of seconds back. Here I need to use the ID. So for that, I'll just go to my code first of all. So let's just open the Jenkins file over here, and this is the Jenkins file. And here I'm using, I'll go through this Jenkins file very soon, but here I need to copy the credential ID, because this credential ID we will be using inside my Jenkins file. So first of all, let's copy this ID here. And here we need to enter the access ID and the secret access key. So either what you can do, either you can go to security credential. I'll just close this one. In the right top corner, there is a security credential section. And here you can create a new create an access key, which will give you the access ID and the secret key for your AWS account. So just copy those keys from here once you generate those access key and secret key, and then you just need to go over here and paste the access key and secret access key over here. I'm just gonna go to my terminal. I'll just open it into another tab for the security reasons, and I'm just gonna copy those details. So first of all, I'm just gonna paste the access ID, and after that, I'm just gonna paste the secret access key. And after that, I'm just gonna click on create. And here you can see our AWS credentials has been created. Now the next thing is, again, go to the home page, and here click on new item, and here we need to enter the pipeline name. So here let's put the dev project one, whatever name you feel comfortable. So just keep a suitable name, and here select on this pipeline first of all, and click on OK. And here we need to now supply the Jenkins file to this particular pipeline. So I'll go back to my ID, and I can start explaining you the Jenkins file. So here in the projects, you will find the Jenkins file, which I have already pushed it. And here you will find the options. So I'll just go and activate it or soft wrap it. So here you will find a couple of options. So this parameter sections, I'll explain it, because these are responsible for creating checkbox, like when you want to run a Terraform plan command, apply command, or destroy command. So these are the checkboxes for these parameters. I'm just gonna run on any agent, because in Jenkins you can have a multiple agents. So I just want to choose any available agents for me. So here, first thing which we will do, we will just try to clone our repository. So here, first I'll try to clean the directory. Then I'm just gonna clone my DevOps project 1 GitHub repository. And once I clone this repository, then I'll just switch to that repository and I'm just gonna switch to that repository using the credential, which is the credential ID, which I have just created, which is this one. And after that, I'm just going to switch to the directory infra. So if you take a look onto this particular GitHub repository over here, then if I go to DevOps project 1, here you will see this is the infra directory. And in the infra directory, you will have a main.tf file. So we need to switch to the infra directory. And once we switch there, then we need to run the Terraform init command. So this is how we are going to run the Terraform init command. And similarly, we are going to run the Terraform plan command also. And here we'll again switch to the infra directory, and then we are going to run the Terraform plan command using the same credential which I have just created, and same for Terraform apply using the same infra directory and the same credential. But also here we have put the condition, if the checkbox is selected, then it is going to execute it, the plan command. And if the checkbox is selected, then it is going to execute the apply command also. So this is the simple Jenkins file which I have created for provisioning the whole infra, which will set up your networking, your all the public subnet, private subnet, internet gateway, then your EC2 instance, RDS instance, then your load balancer, then your hosted zone, then your certificate manager, everything for you. Okay. So now we have seen this Jenkins file. Then the next thing which we need to do is again go back to your Jenkins, and here we are trying to create the pipeline, but we need to point to that particular file. So if you go down over here, then here is it a pipeline script? No, it is not a pipeline script. It's a pipeline from SCM. So here we need to select this option, SCM, like it's for our version management. So here, which is our Git. So I'm just going to choose Git. Then it is going to ask the repository URL. So just go here and go to the repository. Here, click on this one and copy this URL from here. Go to again Jenkins and paste it over here. Since my repository is public repository, so I'm not going to use credentials. I'm just going to keep it blank. But in case if you have a private repository, then just put the correct credential for your repository. All right. Branch specifier, just check the branch. So here I'm working on a main branch. So I need to change it to main over here. And after that repository browser, I'm just going to keep auto. Script path. So again, if you take a look onto, then in the repository, I'm just putting the Jenkins file at the same path, or at the root of that particular repo. So Jenkins files is available right away over here. So here I just don't need to change anything over here. Click on apply and click on save over here. So now our pipeline has been created, but it has not run yet. So let's try to run this pipeline. I'll try to zoom a bit over here. I feel like the font is a little small. Okay, so to run the pipeline, click on this pipeline, click on build now. And here you can see our pipeline had just started. So click on this console output so that we can verify if there is something goes wrong with our pipeline. Here you can see our Terraform init has been executing. It has installed the AWS provider. And these are the different modules which it is trying to execute. So here you can see it's showing you success. And it has only executed the Terraform init because if you take a look onto the plan and apply. So here by default, all these params are set to false. So it cannot run the Terraform plan. It cannot run the Terraform apply. It cannot run the Terraform destroy. So for the first time, it will just run the Terraform init, which we have just seen. Here you can see it's only executed the Terraform init. Again, go back to the pipeline, click on build with params, and here you will find the checkboxes. So now we have seen the Terraform init. Then the next thing is just run Terraform plan and then click on build. And here you can see all the steps which we have configured inside our pipeline. Click on this console output and verify the logs so that if there is anything goes wrong, then we can point those errors, or we can fix those errors actually. And here you can see it shows success. So let's verify the output over here. So here you can see it is planning to add 28 resources, which includes everything. Here it will find all the resources which it will create once we set up the checkbox to Terraform apply true. So let's test our pipeline. So go back over here, click on build with parameters, select plan as well as apply, and then click on build. And now it will take a certain amount of a time because this is a fresh infra which is provisioning everything for us. And also here I'll go to home page and I'll just switch the region to the EU Central Frankfurt, and I'll just click over here EC2, click over here, and here we'll just wait for EC2 instance to pop up over here. So I'll be back and I'll just keep on monitoring this whole logs, and I'll show you the exact output, how it executed after the run. So after waiting for a 4 or 5 minutes, here you can see my Terraform apply has just finished. So that's the pipeline run number 3, which you can see, which has been running green now. And if you check the console output, then you can see there are lots of logs has been generated, but we are interested in the finished success. And here you can see our resources has been added to our infrastructure. So I'll try to refresh this page over here. So here you can see our instance is up and running over here. And let's check our RDS instances. So here you can see our MySQL DB is also up and running. And now we need to access our REST API application. So what you need to do, I'll just open a incognito mode tab over here, and here I will just try to simply access the jhook.org to verify whether I'm able to access the application or not. So here you can see our Flask REST API is accessible. This application is really simple. I don't try to keep it like a very complicated one, but the idea is just to make it communicate with the database, and then you can take that example to implement your own logics for your need. All right, so here you can see this is our API, but the thing is, if you take a look onto our code, which I have shown over here, probably I'll just move this side over here. And if I go to the code, then we need to create a table first. So go to repository and type the Python MySQL DB project. And here in the app.py, first we need to create a table. So here you can see this is the create table which we need to do. So what I'll do, I'll just this is my browser, I'll just copy this URL and go to the tab over here, and I'll just click on create table so that we can create a table. Here you can see our table has been successfully created. And after that, I know it's not the way we should work. We have a Flyway and other tools for doing the database migration, but since it's a demo, that's why I'm just showing you very plain and simple vanilla version of this DB operation. So just keep in mind, just try to use some suitable DB migration tool to manage your like a DDL and DML. All right. Okay, so now table has been created. I'm just going to show you all the tables in the MySQL also. And now we need to insert the record. So let's insert test record 1. I'll just copy the name and click on insert record. Record inserted successfully. Click OK. Here you can see the record. And then 2. Then click on insert. And here you can see. So now I'm able to access my application, and now I'm able to perform some CRUD database operation using the REST API using the Flask Python app. Let's try to access our MySQL database using the MySQL Workbench. So here I have already opened my Workbench. So I'm just going to open a new connection over here. And since we are using our SSH keys, and also we need our SSH connection to go through via our EC2 instance, because that's our RDS instance is running into our private subnet. So here I'm just going to choose standard TCP over SSH. The SSH hostname I'm just going to use. So go to EC2 instance, and here you just need to copy the public IP, paste it over here. Username, we are using Ubuntu over here. SSH key, so I'm just going to supply the private SSH key. So this is the SSH key which we have created, so select that one. Host name, I'm just going to copy the RDS host name from here, copy this one and paste it over here. Port is 3306, that's okay. Root, and for that I'm just gonna use the username. So this is the username I'm just gonna use, and then click on test connection. And here it is going to ask for the password for our database. So I'm just gonna supply the password, which is this one, and paste it over here, click OK, and successfully made the MySQL connection. Click OK and click on OK. We need to supply the connection name. So I'm just going to put demo MySQL DB connection. So I forgot to type the name. Click on OK over here and click here. And here you can see we are connected to our database. And here, if you go to schemas, and here you can see our database, which is dev project DB. And if you take a look, so here it is the DB name, which is dev project DB. And if you go over here and the tables, and here you can see the example table. And here we have the columns, which is like ID and name. So here we can run the query, select star from dev. I think we can run the example table. We need to select the database also. So I'm just gonna select that database. So let's do set as default schema. And again, I just need to rerun that one. And here you can see the record. I think this is too small, but I hope you should be able to see it. I think the records are quite small over here, but here are the records if you are able to see it. Test 1 and test 2 records has been inserted. So let's try to insert few more records. So I'll just close this one over here. And let's insert a 3 record, 3 and 4 insert record. Okay, so now I have inserted few more record. Let's go back over here and rerun the command. Select star, and here you can see the 4 record, 1, 2, 3, and 4. So that's how we have set up our DevOps project. And the last thing which we need to do is to destroy the everything. So here again, I'll just close this one and go to your Jenkins UI, go to your dashboard, go to your pipeline, go to build pipeline, select destroy and click on build, and it will destroy the whole infra for you. So with that, I think we come to the end of this particular end-to-end project. I hope you have learned something out of this project, because this is something which I just wanted to show you, because here you will learn quite a lot of things starting from Terraform, from Jenkins, from your AWS. We have covered a lot of topics onto this particular project. So if you have any question, then please put down into the comment section. And if you are interested into similar content, then considering being a member to this YouTube channel, where I keep on sharing similar, more premium content to my YouTube member. So see you into the next DevOps project. Till then, take care and bye bye.